Welcome to the online platform of KTCD College of Arts and Science. I am RESHMISREE, HoD Department of Mathematics. In this video, we discuss another application of Archimedes property, which is the density theorem. Density theorem states that density of rational numbers in real numbers. Density of rational numbers in real numbers. So the statement is as follows. Theorem is density of Q. Q is the rational set of rational numbers in real numbers. For every two real numbers a and b with a less than b, there exists a rational number r that satisfies a less than r less than b. Okay. For every two real numbers a and b with a less than b, there exists a rational number r satisfying a less than r less than b. So we have to find a rational number r between a and b. Proof is as follows. We assume that a and b are positive real numbers with a 0 less than or equal to a less than b. So our aim is to find a rational number. What are rational numbers? Rational numbers are numbers which can be represented in the form p by q, where q not equal to 0. So in other words, here we take m and n are the elements in natural numbers, and r is equal to m by n, where m and n are natural numbers, so n will never be 0. So we have to prove a less than m by n less than b. The first step is to choose the denominator n large enough so that consecutive increments of size 1 by n are too close together to step over the interval ab. First we have to choose the natural number n. Here the denominator n, 0 from 0 to infinite real number. So the interval is a and b. We have to find a rational number between a and b in the form m by n. First step is to choose the denominator n, long arch. So first denominator is 1 by n, second is 2 by n, 3 by n, etc. In between a and b we find an m by n. So how will you prove this? We have the statement from Archimedes property. What does Archimedes property states that? Archimedes property states that what does the Archimedes property? Archimedes property states that if y greater than 0, then we can find an n belongs to n such that 1 by n will be less than this y. So Archimedes property states that whenever y greater than 0, we can find a natural number n belongs to n with the property that 1 by n less than y. Okay. So here also we are given that a less than b. Okay. We are given that a is less than b. Since a is less than b, b is a number which is greater than a. So b minus a must be greater than 0. So Archimedes property states that whenever y greater than 0, we can find an n belongs to n such that 1 by n less than y. Okay. This is the Archimedes property. So here b minus a is greater than 0. Let's take as y equal to b minus a. Then we get 1. We can find a natural number n that is less than b minus a. Okay. Since a less than b, we can find a natural number n such that 1 by n less than b minus a. This is the second property of Archimedean property. Okay. We have to find a rational number between a and b in the form a less than m by n less than b. Since and here m and n are natural numbers, so n will not be 0. Hence we can multiply n in this inequality. Then we get na less than m less than nb. Okay. With n already chosen, we are chosen an n. The idea now is to choose an m to be smallest natural number greater than na. We have to choose like that. This na must be less than m, or m will be greater than na. We can find such m. So pick an m belongs to n so that m minus 1 less than na less than m. So that m minus 1 less than na less than m. So we have to find an m such that na less than m. We pick m so that m minus 1 less than na less than m. From this chosen, we can write m minus 1 will be less than na. So we can write this as two equations. First equation is m minus 1 less than na, and the second equation is na less than m. Okay. From this equation, we can write a is less than m by n. Okay. We can find an m by n between a and b. So we get a less than m by n. Our next aim is to produce this m by n which is less than b, less than the other real number b. Okay. So how will you prove that? Archimedean property states that 1 by n less than b minus a, isn't it? So we can write a plus 1 by n, that is less than b. So from that equation, a less than b minus 1 by n, that will taken as equation number 6. From the equation 3, we write in the last page that m minus 1 is less than a. So we find an m such that we pick an m such that m minus 1 less than, we pick an m such that m minus 1 less than na less than m. So m minus 1 will less than na. We can write that as m less than n plus na plus 1, which is less than n into, we are given the value a is less than b minus 1 by n in here. Substitute a is less than b minus 1 by n here. Then we get m is less than n into b minus 1 by n plus 1. Multiply n, we get nb minus n by n plus 1. That is equal to nb minus 1 plus 1. Cancelling 1, we get that is m less than nb. M less than nb implies m by n less than b. So we get a less than m by n and here we get m by n less than b. Combining these two equations we get a less than m by n less than b. That is, there exists a rational number between two real numbers a and b. That is the density theorem. Okay, density theorem states that q is dense in R. Density theorem states that q is dense in R. Okay, thank you.